One application a lot of people like right now for advantage is something called SQD. It's a technique for simulating chemistry. And in it, you use the quantum computer to choose what we call a basis, to choose basically how you represent the electrons in the chemical, but then use the classical computer to actually work out what the energy levels are. And the reason why it works really well is the classical computer, when it does that actual calculation of the energies, does that calculation accurately. And so you don't need to correct for the kind of faults on the fly like you normally would. And so it's sort of an interesting example of error mitigation. In that, we're typically seeing runtimes on the quantum computers that are measured in hours and runtimes on the classical computers that are also measured in a few hours. But you can trade them off against each other a little bit. If you have a lower noise quantum computer, you can also make the classical part cheaper. If you have a noisier quantum computer, you can make up for that by throwing additional classical supercomputing power at it. That's part of why it's such a neat application in the near term, that you can trade the two off.